Greetings all, welcome back. Today I want to talk about, in some sense, this entire class is going to be about differential equations of various forms with various structures. And to be able to talk about a generic differential equation, we do need to have some information about it. We talked last time about order, the order of a differential equation just being nothing more than the order of the highest derivative of the unknown function within the differential equation. Today, I want to be able to talk about a generic or a general differential equation of a particular order. And to do this, I want to basically define what's called the general form for a differential equation. So we'll start here with the definition. And I'll use a couple of colors here. The general form of an nth order differential equation is given by the following, and it's a function with many inputs, so you may want to think this is not really like single variable calculus, but it really is a function with many inputs, x, y, y prime, up to y, n in parentheses there, equals 0. And I want to mark this as star. Now, what this is an expression that has a lot of inputs. It has our independent variable, which is this guy, the x in this particular case, that would be sort of the time thing, a dependent variable, which is y, and then it has the various derivatives. Now, we use this notation of putting a numeral inside parentheses to denote not the power of a function, not y squared, but y's second derivative if it's in parentheses. So these are all derivatives. So to give you a sense for what these guys are, x here is the independent variable. In essence, time. Y is the dependent variable. In essence, the unknown function, that's the thing that we're looking for. That's the mathematical model, y is a function of x, that we're trying to find. The other parts here are y, I, and I in parentheses is the ith derivative of the unknown function y. And then f is just some expression involving the y's and x. And in essence, it can be anything you want. It doesn't need to be continuous on some big interval or something. That's a question for another day. But it does basically give a sense for we can talk about the generic, the general form of an nth order differential equation as just being one big expression involving all the x's, the independent variable, the y, the dependent variable, and the various derivatives. Setting it equal to 0 just sort of gives us a sense for what's actually going on here. Now, sometimes, and I'll put this over here, sometimes we can actually solve for the highest derivative, the nth derivative. And we tend to like this form because it's going to be useful for us in the future when we're developing some other things. But if we can, then this generic form will take a slightly different form. It'll look like the nth derivative equals some big function, and I'll use g this time, of x, y, up to y to the n minus first derivative. This is not really the most general form, but it's a pretty generic form that's going to be useful for us at times, depending upon what our analysis is going to be. And the reason why I'm writing this is that sometimes we cannot write this way. Any differential equation can be written in this form, where you just take everything, it is an equation after all, you take everything and bring it over to the left-hand side, and you basically just call this a differential equation of order n. Some of these guys cannot. And to give you a very brief example, if I wrote For some unknown function, its fifth derivative plus the sine of its fifth derivative, that's possible, equals its third derivative. Tell me a function whose fifth derivative plus the sine of the fifth derivative equals the third derivative. Well, I don't know what that function is. We're not going to deal with these in this particular class. But in this particular case, I can't solve for y to the fifth here algebraically. I can't separate that. I can't write that in this form. So I can put it in this form by just bringing over the y to the third, and then my capital F would be y to the fifth derivative plus sine of y to the fifth derivative minus y to the third derivative equals 0. So I know what my f is, but I can't write this as this g. So what we're going to do for the most part is this is going to be what we call our generic or general form for an nth order differential equation. And when we want to limit ourselves to basically looking at forms like this, well, then we might have to throw out some of these harder ones. But you know, that's okay. That's pretty much how it works. Anyway, that's enough for this moment. Thank you for listening, and we will talk to you again very, very soon.